Okay, so we did a ranking task today in class, and I wanted to take a few minutes and go over that and go over some techniques. Now, ranking tasks are what I consider a lateral thinking exercise. So I'm never going to ask you a ranking task on a quiz, but they are a good way to stretch your brain and to see how well you really understand what is going on. And so to put it in perspective, by the way, we are on page 110 in your workbook. And I did not put the questions on here. I just put the pictures so I can draw all over them and go through them. But the first two, the way that we ran the class was I had you pair up and then I had you spend 5 minutes going over the first two, which is rank the above situations from greatest to least based on the time to hit the ground. All right, so in case you don't have your book in front of you, we're going to do the time it takes to hit the ground, and we're going to rank from greatest amount of time to the smallest amount of time. Okay, we can use equal signs. We're going to use the greater than symbol, and you can have ties. All right, it says make your ranking in a single line using only the greater than and the equal signs. Ties are possible, and then explain the reasons. So everybody broke up into groups, and they did their ranking, and then pulled you into a big group and said, okay, what's going on here? How did you decide what was going on? Because if we take a look, what we'll see, like I'll look at letter E. You've got the height, you've got the mass, and you've got velocity. And so which of those factors is the most important, or are multiple factors important in figuring out the time it will take to hit the ground? So when we got into the first circle, notice that, we had a lot of variation on our answers. Most folks realized fairly quickly that mass is not a problem. We did actually also realize that that one looks like a 2M, even though it's not written there. So right away, folks said, okay, no to the mass, but what about the velocity and what about the height? Like, which of these matter? And so because there was some debate and we could not figure out which one it was, I pulled out a device that I have in the back room. Here's a ring stand, and I have this device on it. And what it allowed me to do was to take one object and then two objects, and I could actually shoot one sideways, and I could drop the other one, and it would do it instantaneously, like exactly the same time. And we had somebody else videotape it in slow-mo and see if if it took the same amount of time to hit the ground. One of them was lighter than the other. One was a hex nut and one was a ball bearing, and so we were able to then record. And hang on just a second. Okay, so what we were doing was we had one that was lighter than the other, and we shot one out to the side and we dropped the other. And what we videotaped is that they hit, this one of course is going to go in a parabolic motion, and this one is just going to go straight down. But they hit at exactly the same time, video proof. So what that meant to us is that mass doesn't matter. Velocity in the horizontal direction doesn't matter. The only thing that matters is the height. So if we take that into consideration, we just say, okay, there's 2h, there's 2h, there's 2h. These are higher. These are going to take longer to hit the ground. So D equals F equals G equals I, and these are bigger because, let's face it, it's higher, it's going to take longer to hit the ground. This is bigger than A, which is equal to B, which is equal to C, which is equal to E, which is equal to H. And it was a fairly straightforward, let's figure it out from there. Okay, so that was our those were the first two questions. Then what we did was we went to the next two questions. I repaired everybody up and said, okay, let's figure out this next one. It says rank the situations from greatest to least. All right, so again, we're going from greatest to least based on horizontal distance, delta x, of the sphere from the edge of the table from the time it takes to hit the floor. Make your rankings in single file. Okay, so now this one, I'm going to give you a few minutes, and I should have done this in the last slide, so I apologize, but you probably want to take a few minutes, pause the recording, and try this yourself. See what you think. Which of these is going to have the greatest horizontal range? So I want to know this way, like how far this way it's going to go, delta x. Okay, see if you can rank them the same way the previous ones were ranked. So take a moment here and pause the tape and pause the video and give it a try. Okay, you're back. Good. Now let's see about going over the answers. Chances are you have kind of a mishmash of things, but it's pretty easy to say that that one is going to go the furthest, and this one is going to go the least because it's just being dropped. It doesn't have a horizontal distance, and this one is the tallest and the fastest. Again, probably figured that mass doesn't matter because it never seems to, and that's true. So you've got your extremes, but what you also realize is that you're taking two variables into account. So this becomes tricky, like which variable matters more? If you think about it, that's kind of an important question. Like for example, if I compare G to H, it's pretty easy to say, okay, well G is going to go further than H because the heights are different, right? They have the same velocity and the heights are different. But what if I compare, for example, what if I compare G, or I could even compare G to A, but what if I compare, I don't know, G to F, right? G to F, they have the same height, and then the velocities are different. So you say, okay, well that one will probably, this one will go slower, but what if I compare, you know, this one or this one? Like where does the importance come in? There's going to be some mess in the middle. So there's got to be a way for us to find the mathematical relationship between them. Otherwise, it's just a matter of guessing. And you can, it's complicated. So what I did then for the rest of the class was I went over how to find it. And so again, I'm going to preface this by saying it will not go on a quiz. So don't freak out, but we can use some mathematical models and figure out what the heck we're doing. So let's start at the beginning. What do we want to know? We want to know delta x. How do we find delta x? Well, I need to use the x graph, and I want to find the area under the curve, and here's my time. So what I need in order to find delta x is I need to use velocity and I need to use time. Now velocity is easy. They give you the velocity right there. But what about the time? I don't have a number for time. All I know is that 2h is more than h, but I don't know how much more. So that's a problem. So let's use the vertical to figure out a value for time. And we've done this before. So here's Vy, time. We're going like this. The one thing I'm going to do here that you guys tend not to like is I'm going to work in variables. You like numbers, and we're going to stick to all letters. It's not your favorite, but you'll manage. Okay, and this I'm going to call delta y. So the slope of my line, as we know, is 9.81, or negative 9.81, so that's little g. Vf is my final velocity in the y direction. T, I could call that T or TF. It doesn't really matter. Ti is 0. Delta y, that's where the height comes in. That's the area under the curve. Since I have two values for that, I'm just going to leave it at delta y for a little while. So what do? I work with the slope, and then I work with the area under the curve. I've done this before. All right, so the slope is going to be Vf divided by T. I don't like fractions, so Gt equals Vf. Great. Then we work with area under the curve, right? Delta y equals 1/2 base times height. Okay, so what's that? Delta y equals 1/2. The base is time. The height is Vf. Oh, look, I know what Vf is. I can go right there. So what I'm looking at, delta y equals 1/2 gt squared. And I did actually mention that for those of you that are looking online trying to find help with projectile motion and avoiding coming and talking to me, you're finding a lot of formulas and like, dang, why doesn't this lady just give us the formulas? This would be so much easier. You are using the formulas. You're just deriving them as you go when you need them. This actually is a formula, and that, you know, that typical physics people use, but they don't know where the heck it came from. You guys do. It came from slope, came from area under the curve. Now, I'm going to take this and rearrange it for time because that's what I need. So I'm going to multiply both sides by 2. That's a delta, by the way. It got a little dodgy looking. All right, gt squared divided by g. And then let's square root that. All right, so 2 delta y over g equals t. Okay, we're almost there, you guys. We're almost there. So what ends up happening now is I want to define these in terms of h and 2h. So h. If you have a height of h, what is your time going to equal? Well, your time is going to equal the square root of 2h over g. Now, I'm going to take that. If my height is 2h, then t is going to be equal to the square root of 2 times 2h over g. And as you can tell, that's going to be 4 when you multiply it together, and the square root of 4 is 2. So I can rewrite that as 2 square root of h on g. That's the value of the time if you're at 2h. This is the value of the time if you're at h. Now, you're like, oh God, now my head is going to explode. How am I going to fix this? All right, we're almost there. I promise, I promise, I promise. All right, so for each of these, I want to do area, or I'm sorry, let's erase that. I want to do delta x equals v times t. And let's face it, I know what the t's are now based on the height. I have formulas for those. So if I have height h, my formula is going to be square root of 2h over g. That's going to be the time. Now I'm going to rewrite this, and you'll see why in just a minute. Just bear with me here. I'm going to pull out the square root of 2, and I'm going to multiply that by the square root of 2 of 8 of h on g. Now if I have a height of 2h, we already said we know what this one is. It's going to be 2 times the square root of h on g. So when you compare them, if you take a look, doubling the height doesn't necessarily double the time. I mean, the first one is just the square root of 2. The second one is 2. You can make a ratio and figure it out, but nah, not today. All right, so what I want to do for each of these is I want to multiply v times t in each case. So I'm just going to overwrite each of the pictures, and then we'll do some comparisons, okay? So let's start with A. I want to multiply v. All right, so I've got v here. Right, there's my v, and I know the height is h. So I'm going to say times square root of 2 square root of h over g, because that's the time that I have. Now, if I rearrange that, I'm going to get square root of 2 v square root of h on g. I don't know what that means, but we're going to leave it there for now. Now, I'm going to move down. I think that'll just be a little bit easier for me to work with for a little bit. So let's go to D. All right, so I want velocity times, and this is 2h, so I'm going to say times 2 square root of h over g. All right, let's rearrange that. And here's something I want you to notice. Look at this. Look at that, what I've got written there, and compare it to that. They're the same. There's no comparison. So now, if I compare this and this, and I asked you which was bigger, you would tell me, I sincerely hope, that this one is bigger. This is how we're going to tell, this is how we're going to rank them. This is how we're going to be able to rank them. Okay? This piece right here and here, that's going to be the same on every single one. And then we're going to have a different number in the front that we're going to be able to use to actually solve the final problem. I think that's so cool, because now we have a way to do the time. Now again, this is a little more than what we normally do in the class, but I wanted you to see how we can do some of these comparisons. It's kind of neat, and how we can use the graph to do it. So again, lateral thinking exercise versus a vertical thinking exercise. All right, here comes our next one. Let's just crank through these now, because you've got the idea, right? So my velocity is 2v. I've got 2h, so I'm going to multiply that by 2 times the square root of h over g. So if I rearrange that, I'm going to get 4v square root of h over g. No wonder you chose this one, right, as being, no wonder you chose this one as being bigger for everybody else. And now let's go through the rest. All right, so v on 2, the height is going to be square root of 2, square root of h on g for this one. So this one's going to be square root of 2 over 2 v square root of h on g. All right, again, let's circle that. That's the square root of 2 on 2. This one's just going to be 0. How nice. Take a break. There's that one. Let's look at this one. So we've got 2v times the square root of 2 times the square root of h on g. So 2 square root of 2v square root of h on g. That's going to be the number we work with. All right, v times square root of 2 square root of h on g. 2v square root of h on g. There's the number that we need. V times 2 square root h on g. Again, if you're lost, I'm doing the velocity times the time. And I'm just moving things around because I'm just classifying it into stuff that is unique and stuff that is the same for all of these expressions. And then last one, we've got v on 2 times 2 square root h on g. So 2 times 1/2 is going to be 1. I'm going to actually write the number 1 because it will make life a little easier later. Okay, almost there. Now it's time to rank them. All right, remember we're ranking from bigger to smaller, and I'm going to cross them off as I go because I want to be able to remember where I am. All right, so obviously the biggest one here is g. All right, g is totally bigger. All right, after that you might be tempted to go to the 2, but 2 times square root of 2 is actually bigger, right? Because square root of 2 is about 1.4, so 1.4 times 2, that's a bigger number. All right, so g is greater than h. All right, after that, let's look around a little bit. We've got the 2's. All right, so that's d. So that's greater than d, but we have 2 of them. So that's equal to f. All right, so we took care of those. And then what comes next after 2? What's our next one? All right, we've got square root of 2, we've got square root of 2 on 2, and we've got 1. All right, so square root of 2 is about 1.4, which is greater than 1. So these guys up here, these are going to be my next ones along the way. All right, so this is greater than a, which is equal to c. So got those taken care of. Next, I can go, which is greater than the number 1, when that one is letter I, which is greater than, I'm almost out, so it works out. I can go greater than b, right? So 1, and then there's the square root of 2 on 2, and then finally is greater than e. So there you have it. That's how you can use math to figure out this ranking task. No calculator required, but it is a little bit different than what we're used to. Don't be afraid. All right, variables won't hurt you. And yeah, so hopefully you learned a little something from there.